Students, the next topic is inverse of a function. So let us see the understand the inverse of for the function f from a to b, from the function f from a to b, to exist the inverse, the function that inverse of the function will be g to a. So that you have to remember, b to a, g is the function, but if a f function is both 1 1 and onto bisection, only the inverse of the function will exist. This is the main point you need to remember here. And if you see that the example here, if f is a function given to you, the inverse of the function f of x is denoted by f inverse of x, and the read as a f inverse of x. A function f of x will have the inverse only if it is both 1 1 and onto, both 1 1 and onto only, then it is possible. So if the g is the inverse of the function f, then f circle, already you have learned the composition of the functions. F circle g, fog, fog will be equals to gof. If it is, then that is possible here. Okay, next let us go for the next. For the function f of x is equals to, the inverse of the function is f inverse of x is equals to root x. F inverse of x is equals to root x, and here the root x stands for the positive square root only. Do remember here. So f of x is equals to x square. X square is nothing but, here as an example it is given to you 1 square 1, 2 square is 4, and like this if you are taking all the numbers, mapping is given to you, just it is given to you, and root x is nothing but reverse. The function should be b to a, so then only then it is called as a its inverse. Okay, f of x is equals to x square is given from the natural numbers to the, and as an example if you see that this one here, this function is not a 1 1 function, but it is a 1 1 function, sorry, it is a 1 1 function but not onto function. Why? Because here all the elements are not having from the codomain, all the elements, here all the elements are not having the pre images, that's why they are not a onto function. So if it is onto function, if the function is given to you here like this, then here it is not at all as if it is not at all function here, this is not a function here. So since it is not a function, then you can say that the inverse is not possible. So that's why the main thing you need to remember, that here some elements have the not a function, that is okay. So for the function f of x is equals to x cube, if you have saying, the inverse is cube root of x, cube root of x for the real values only. Okay, so here some examples are given to you, f of x and f inverse of x, how it will be there. X to the power of 4 means 4th root of x, x power n means nth root of x, and a power x is nothing but log x to the base a, e power x is log x here. Okay, so these are the things you need to little bit remember here to understand them. And let us see here, 1 1 function is nothing but a function f from a to b is said to be 1 1 function or injection if the different elements of a have the different images in b. Already we have discussed in the types of the functions, so let us recall this one. So that means here already we have learned these all the things previously. Once again recalling the working rule to check the 1 1 function is already you solved the problem in the exercise 2 also. Once again this is a recall for that. Okay, and onto function, how do we check if it is an onto function? If the here f of capital A will be equals to b, then the range of the f and codomain should be equal, then it is called as a onto function. So this is a working rule for checking onto function is, consider any element from the codomain such that f of x is equals to y, and express the x in terms of y, and that x should contain in the domain. So then x belongs to the domain, the function is onto, otherwise it is not an onto function. Okay, thank you students. And working rule, let us see here exercise problems, all the problems based on this together. Okay, thank you.